Okay, let's go ahead and take a look at our energy foldable. I had typed up when it's due. It's going to be due next week in class. Whether it's Monday, Tuesday, Wednesday, Thursday, whatever day you have, it's going to be due next week in class. And that would make it, I want to make sure that I give you the correct answer or the correct date because I don't want to say the incorrect date and someone gets confused because I do that on accident. But it's going to be due on week 13. So anywhere between March the 29th through April the 1st, depending on which day you have class. Okay, so you've already done the videos, the energy video over work, kinetic energy, conservation of energy, gravitational potential energy. Then after that, you did the cleaning the air, and you also did the video Eureka. You submitted and turned those in. They were due through Blackboard, and you had 1 hour after your class time was over to get it done and turned in. Now, let's go ahead and work on this foldable that is going to be due, and it's going to be a grade, and it will go on this report card that we have coming up. April the 1st is the last day to get anything turned in for the report card. Okay, April the 1st. After that, your grade is going to go in as is. So if this is not given to me, then it's going to go in as a 0. If for some reason you are absent because you're quarantined or whatever, you must email it to me, every page, by the time your class starts. So if your class starts at Wednesday at 8 a.m., then I need to receive the email by Wednesday, 8 a.m. Anytime after 9 o'clock at 9 a.m. or 12 p.m., it's going to be considered as late. So I wanted to make sure that we knew that. So hopefully you started off with grabbing your paper and then fold it up like a book. 1, 2, 3, 4, 5 pages. I don't care if you use notebook paper or just regular plain white printer paper, whatever paper, construction paper, whatever paper you have. Fold 5 papers in half like a book. Let's go ahead and staple it. And if you don't have any staples at home, don't worry about it, because when you come to class, then you can staple it. Make sure you write energy foldable at the top and make sure you include your name on it. Now, I'm going to first show you what the pages need to look like. Okay. Also, I'm going to show you and make sure I let you know what the point values are. So on page 1 and page 2, it's going to be this paper that looks like this. You're going to first tape. Energy is the blank to do blank or change blank. You're going to fill this in first. You're going to have this on this page. So this is page 1 and page 2. Page 1 is worth 3 points. Page 2 is worth 3 points also. Okay? It's one sheet of paper that I just taped over the whole thing. Next page, page 3 and page 4 is going to be one page because there's like 11 pages you printed out. And that's going to go over here. Page 3 is worth 3 points. Page 4 is also worth 3 points. Page 5 and page 6. And you can pause this if you need to. You're going to have this little chart over here that's worth 3 points. And page 6, you're going to have this chart. Please tape it to the top because I have more to write down. It's also worth 3 points. Page 7 and page 8. Page 7 is worth 4 points. Page 8 is worth 5 points. It is one page, and you're going to cut it out and you're going to tape it on here. Be careful when you put tape, because if you tape so much onto the actual paper and you try to write over tape, it's really hard to see. It may even smudge and come off. And then I'm not going to see that you actually wrote anything down. So please put the tape right on the edge and not on top of the paper so much. Page 9 and page 10. Page 9 looks like this, which is worth 10 points, and page 10 looks like this, and it's worth 10 points. Let's make sure. Page 9, the first question is, what is energy? Page 10, question number 1 says, energy of motion. Okay, so please make sure you have the correct. I'm going to go through quickly and grade them and see what you got right, what you got wrong. I don't have a lot of time for incorrect pages. I'm telling you right now, you must tape things down to the correct page number. Let's go to page 11 and page 12. Again, this is one full sheet of paper that I just folded in the middle and then just put right here, taped it on both sides. Page 11 is worth 3 points. Page 12 is worth 3 points. Next one, page 13 is going to have more questions, and it's worth 10 points. The first question says, why is it beneficial to use natural gas? Okay, page 14 looks like this, and it has this kid on the skateboard. Tape it in sideways, and it's worth 10 points. Page 15 looks like this. It's worth 2 points. It has this cannon that's shooting up, so tape it in sideways. And page 16 looks like this. It's worth 5 points. There are 2 questions. The first question is a rifle that's shot at, shoots a 4.2 gram bullet. The second question is a hockey puck is accelerated using a hockey stick over a smooth, level ice surface. Okay, so page 16 has those 2 questions on it. Those are the 2 questions that must be on page 16. Page 17 must look like this. It's worth 10 points. I mean, if you put something else on page 17, I'm just going to count it wrong, and that's 10 points. It's not worth it. It's going to start off where it says KE practice, so for kinetic energy practice 1 through 5. And then you have a question at the bottom. A 1,500 kilogram car is traveling at 25 meters per second. Next one, page 18, which is the last page, is worth 10 points. At the top, your questions are going to be elastic PE, or elastic potential energy, questions 1 and 2, A, B, and C. And then the bottom question is a spider monkey that has a mass of 40 kilograms. So please make sure you tape everything correctly. Let's go ahead and begin and start to fill in the blanks with our notes. All right, so let's go ahead and begin. It says here that energy is the ability to do work or cause change. Right? It can accelerate, decelerate, stop completely, change directions, whatever it is. Oh my goodness. Let's see what else. Here's the next one. Got it. The next one is we're going to talk about alternative energy resources that rely on natural processes and can be used to produce energy. And used to produce energy. For a resource to be considered quote unquote green, it must be renewable and clean. Okay? Now, renewable versus and clean. Let's talk about what those words mean. Renewable means the supply must be continually available. Okay? Clean, that word, that means having few or zero carbon emissions. For an example, what we're talking about, carbon emissions, CO2, and few toxic byproducts. Okay, let's keep going. So, renewable versus non-renewable. All types of energies are either going to be renewable or non-renewable energy. And let's talk about those, and let's talk about the examples. Renewable energy. Renewable, also called alternative. Okay. And these are another option or alternative to non-renewable renewable. These products are less waste, or they produce, they produce less waste and can be replenished by nature in a relatively short amount of time. What do we mean? Examples: trees, plants. Don't get me wrong, I understand some trees take hundreds of years to get to the point where they're at fully grown. We're not talking about that. We're talking about trees that can grow to a certain height or a certain maturity within, 5 years or so, or 3 years. And even though 3 or 5 years seems like it's long, that's relatively quick compared to coal, okay, which takes millions of years to form down under deep in the earth. Now, our examples of renewable. There are 5 types of renewable energies. We have solar. We have biofuel. We have geothermal. We have hydropower. We have wind. Okay, let's keep going. Let's talk about the non-renewable kinds and what they are and their effects and their issues. It says here that they have a fixed amount once they are used up. It takes millions of years to make more. They produce hydrocarbons, pollution, or pollutants that harm the earth. And we have 4 types of non-renewable energy. First one is nuclear. Second one is natural gas. Eventually we're going to run out. Oil and coal. All 4 of those we are eventually going to run out. We're not going to have enough of. And one day there's not going to be any more. For an example, when you get in your car and you drive your car, you use oil, and we're going to run out of oil with all the vehicles and everybody driving. Okay. And we use oil for other things as well. But what happens then when there is no more, or when there's very little bit of oil left? The price is going to go sky high. Alrighty, let's turn to the page to 3 and 4. It looks like this. Okay, so let's look at this one. We're talking about alternative renewable. Okay, so there are 5 sources of renewable energy, right? Wind, solar, hydropower, geothermal, and biomass. We're going to talk really quick about how it works, the advantages and the disadvantages. And I know it's a little difficult right here to see on that little seam. See what you can do to get that opened up so you can write on it. It says here that how it works for wind. Wind spins the turbines to make electricity. Turbines. Have you never seen these wind turbines? They're amazing. To make electricity. Oh, that's my electrons. Let me just go ahead and write electricity. Okay. Solar. Solar says here sun rays are captured in photovoltaic cells. Sun rays are captured in photovoltaic cells. Next one, hydropower. Hydropower is moving water. And it spins the turbines that are under the water. Oops, I missed a B. RBIN. Turbines, and makes electricity. The next one is geothermal. Now, geothermal is heat from deep inside the earth. Heat from deep inside earth. Okay. The next one is biomass. And biomass is actually dead plants that are burned for fuel. Okay. Next one, the advantages and disadvantages. So let's start back up at the wind. The advantages and the good things that when it comes to wind is that there's no emissions to low cost after it's built. So no emissions is one great thing. We're talking about those hydrocarbons. And it is low cost after built. Oops, that's an LT. So once you build it, there's not a lot of maintenance that you have to do to it. Yes, you do have to do maintenance, but not a crazy amount. You don't have to have all of this equipment and all these hundreds of people to keep up with it. Nope, it's really low cost maintenance. Solar is actually non-pollutant, right? Non-pollutant at all. It's just the sun that's coming from the sun rays that are coming from the sun, from outer space. And not only that, it's non-pollutant, but it is the most abundant compared to all of the other renewable energies. When it comes to hydropower, there's no emissions at all. No emissions, none of those hydrocarbons. Okay. And it's very reliable. I mean, how many days do you not feel the wind blowing or breeze? Don't get me wrong, there are days, but they build them really high up and they build them in locations. I'm sorry, I was thinking about wind. Hydropower. When it comes to hydropower, that's just the water flowing on top of the turbines, and you know where the water is located. You know where the streams, the rivers, the dams are built at, and you build and you make the turbines under that water, and there's water that's continuously flowing. And so that's the reason why it's reliable. You know exactly where it's at, and it's going to continue to come. The water continues to come, and it turns the turbines. Geothermal is little impact on the environment and low emissions. And then the last one, biofuel, makes auto and diesel fuel. It helps. Makes auto and diesel fuel. Okay. When you go to the gas station and you're putting gas into your car, and you see that the pump probably says something like 10% ethanol, right? 10% of corn plants or some kind of wheat plants are probably used to make that fuel for your car. Okay, it has biomass inside of it. That's what that little sign means when you're putting your gas in the gas tank. Now, the disadvantages, because even though there's good things about it, there are also bad things. So wind only works when the wind blows. Okay, so the majority of the times they actually build it along the coast, because the coast, there's a lot of convection currents that are coming off of the ocean. And so because of that, or the bay, they build the wind turbines there. But there are a few days that it's not very windy. Okay, so the disadvantage here is that it only work when wind blows. There's no wind, then it's not working. The other thing is that it's low cost after it's built. But to actually build the wind turbine, it's very expensive to build it for the initial build. Okay. The next one is solar. Solar, again, for the initial build, mainly, it is very expensive. And here's the other thing about solar. It depends on sunny days, right? Because some days it's cloudy and some days it's sunny. And so only on those sunny days is when you're going to get great solar sun rays that are shooting down. Now, the next one, hydropower, which is the water, changes the environment and it's expensive to build. So changes the environment and expensive to build. Now, they know exactly where these streams and rivers are, but for them to build the hydro plants there with those wind turbines, they actually have to first do a lot of construction work, build a dam, stop the water to flow completely. And then after that, then they can build all of that on there. And then after they build those turbines under the water, when they allow the water to come back in to start flowing again, they actually have to build up these dams to hold up back some of the water, because there are times where it's too much energy or they need to slow it down. And so that's going to cause the environment to change up from the natural state of that river flowing through to now we have a dam that controls how much water goes through it. The next one, geothermal. Geothermal is expensive. Startup. And it's actually not everywhere. Okay, so it's going to cost a lot to start off building and getting these geothermal turbines and plants ready, but you can't just dig wherever you want to. There's certain locations where they can dig, and then yes, they're going to have this heat from deep from the earth popping up and coming up. Okay. The last one is biomass, where we have some. So the biomass is, there actually is some pollutant or some pollution. When you burn your gas, and we got a little bit of pollution really coming out of your car. So there are some, and you have to, the cost to transport it. Okay. So you make it here, but yet it has to travel all over. Alrighty, so that's our renewable energies, and there are 5 kinds. Next side, or the next page. The next page over here is it's going to be our non-renewable energies. There are 4 types. We got coal, oil, natural gas, and nuclear. All right, so the good, the bad, and the ugly. Let's talk about some advantages, some disadvantages, and some things that are just not okay when it comes to these non-renewable energies, because once we use them up, we're not going to have any more left over. So coal, okay, they're not good, or I'm sorry, the good thing about them is that more hydrocarbons. They're twice the energy as wood. They're very cost-effective plants. Okay, so more hydrocarbons for more energy. Twice the energy as wood, and cost-effective. Plants. Let's keep going. Good things about oil. There's an abundant supply. Now, don't get me wrong, we are using up a lot of what we have, but there is an abundant supply. The problem, though, is that you've got to find out where this oil is. And some of this oil might be in other countries, and they're not going to let you go over there and just start digging and pulling out their oil. Okay, so we have an abundant supply. It's pretty easy to find. We know how to find this oil now, whether it's on land or whether it's on under the sea. Easy to find. 3 times the energy as wood. Alrighty, 3 times the energy. Oops, GY as wood. And pipeline transport. It actually transports through pipeline. So pipeline transport. The next one, natural gas, an abundant supply. We do have a lot. Yes, eventually we're gonna run out. It's, again, easy to find because we know how to find these things. It burns clean, which you saw on that video. And it's 3 times the energy of wood. And again, it's pipeline transported. Nuclear energy. Believe it or not, there's some good things when it comes to nuclear energy. It emits low amounts of CO2. Believe it or not, there's a couple of good things. Emits low amount of CO2. That's a good thing. It produces large amounts. Produces large amounts. And large amounts, I guess, of energy. Let's go ahead and look at some bad things, because there are some bad things when it comes to these non-renewable energies. When it comes to coal, they can cause global warming. Can cause global warming. Mining destroys the actual environment, whether you have to mine it underground, on land, or under the ocean. It messes up the environment. So, mining destroys, DESTRYS, environment. When it comes to oil, it takes years, and I don't mean like just years, it takes millions of years to form. And to drill for it can actually destroy, again, habitats. We're going to run out of it. Okay? We're going to run out. Natural gas takes millions of years to form. And for the natural gas, to drill for it, it's going to destroy the environment. And I don't know why I didn't put an R. DRILL. Drilling destroys environment, the habitats, environment. Next one, nuclear. Accidents and spills actually can happen. You've probably heard of Chernobyl over in Russia. There's other places, not just Chernobyl, but there's other places where they have had accidents, and now you have, all of this toxic radioactive waste that's in polluting the land or the water or the air and cancer causing. So this is not good when you have an accident. It's not just like, oops, I made an accident. This is a bad one. So accidents and spills can happen. There are times where people do it on purpose. Like they know that they have all this extra toxic radioactive waste, and instead of disposing it properly of it, they just pour it down the drain, pour it in an empty, land area. But that doesn't mean that it just stays there. It seeps into the ground, and it's not a good thing. Uranium, because it's made from uranium, and polonium